Question number 2. It says consider 100 samples x1, x2 up to x100. So we have 100 samples x1, x2 up to x100. They all are IIDs. They are IIDs with the distribution normal with mean mu and variance 1. The null hypothesis is defined as, let's denote the null hypothesis as mu h naught, and it is defined as mu equals 0, and the alternative hypothesis is mu greater than 0. So this is basically our right till test. Suppose the test statistic t equal x bar. Okay, so the test statistic is given to us. Test statistic t equal x bar. Consider a test that rejects h naught if t is greater than c for some constant c. And what is the test? The test is that we reject h naught if t, which is nothing but x bar, is greater than c. What is probability of type 1 error? This is our first question. Probability of type 1 error. And we know that probability of type 1 error is denoted as alpha, which is also the significance level of the test. It is defined as probability that we reject our null hypothesis given the null hypothesis is true. Okay. So when are we rejecting h naught? We are rejecting our h naught when the test statistic t, that is x bar, is greater than some value c, some constant c. And this c here is the critical value. Okay. So reject h naught. So we are rejecting h naught when this x bar is less than c, given h naught is true. H naught is mu equals, so mu equals to 0. Now let's convert this x bar to the standard normal form. Okay. So what is the mean of x bar? Mean of x bar is going to be mu, right? And mean of x bar is going to be mu. And variance of x bar, that is nothing but sigma square by n. It is 1 divided by root n. Okay, root n is 100. And where is this 1 coming from? 1 is, you see that here, x1, x2 up to x100 is IID normal with mean mu and variance 1. So from here, we are taking the mean to be mu, the expected value of x bar to be mu, and the variance to be 1 upon under root of 100. N is the n is the sample size. Okay, 100 is the sample size. The same thing we'll have to do on the right hand side. It becomes c minus mu divided by 1 upon root n, given mu equals 0. Okay. Now we know that this x bar minus mu divided by 1 upon under root 100 is nothing but rz. We can write this as capital Z. Okay. And this is after substituting mu equals 0. Same thing, if you put mu equals 0 here, it becomes c minus 0 divided by 1 upon under root of 100. So it is 10c. Now this is what? This is nothing but 1 minus fc of minus 10c. So the correct answer here is, sorry, this is negative, positive 10c. So how is this coming from? How is this coming? It becomes 1 minus probability. This can be written as 1 minus probability z less than 10c. And we know that this probability z less than 10c is fc of 10c. So this is our correct answer. Here it is option P. Now the second part of the question asks you to find probability of type 2 error. Okay. So what is the definition of probability of type 2 error? Probability of type 2 error is equal to probability that you accept h naught given HA is true. Alright. Now when are we going to accept h naught? Since we were rejecting h naught if t were greater than c, then we will accept h naught when t will be less than equal to c. And HA is true, that is given to be mu equal 1. right? So t was taken as x bar. I can just replace this t as x bar, and now we will convert this x bar to z, right? So probability mod of x bar minus of mu divided by sigma upon root n. So sigma is 1 divided by root of 100 less than equal to c minus mu divided by 1 upon under root of 100, right? Given mu equal 1. Now this whole term is going to be z, capital Z. So probability capital Z is less than equal to c minus 1 divided by 1 upon 10. So this 10 I can write it here. And this is nothing but fc of 10c minus 1. So this is going to be our probability of making type 2 error. So the correct answer is D.